Hello, my name is Andrew Wang, and this is Physics 2112 Lab 1 video. So, the introduction. The purpose of the lab was to use tapes to demonstrate the interaction between objects of two charged things, or different charged things. In this case, that would be the tape. And then simulate these tape interactions using glow script coding. And then using this code, we would calculate the charge of the tape and forces applied using relevant physics formulas and concepts, which would be the Coulomb's law, Newton's second law, F equals ma, the concepts of electric fields and forces. So we would use that in this lab. And then in this experiment, the system of the tapes and the surroundings is everything else in the universe. So what you would do is you would combine two tapes and then yank the two tapes away from each other. One tape would take all the electrons from the other one, meaning that one tape is negatively charged, the other positively charged. And you would do this twice. So you would have two negatively charged tapes called U tapes. So you would put one of the tapes across the table, and then you would take the other tape under the gap. You kind of bring closer. And what would happen is, because both the tapes are negative, the tapes would repel. And then what would happen is that one of the tape is like floating. So the distance the tape repels is the separation distance, which we measured at 0.0254 meters. And based on the length of the tape we used, we estimated that the tape mass was about 0.0002 kilograms, meaning the gravitational force of the tape was 0.00196 newtons. And because it's floating, that means the electric force magnitude and the gravitational force magnitude had to be equal to each other. So how do we use this? So if the electric force is what we found as gravitational force, 0.00196, so we can plug that into this formula, and then you can plug in 99 as K, and then you can plug in the separation distance as R, and then because the charges are the same, it will just be Q squared, and then you can find Q. And then we apply this formula into this code, and this is the code. So you would put in these variables and the formulas there in code form, and then on the bottom you can see it's modeled. And then on the left side, the magnitudes is printed out. They're the same, obviously. And then the charge of the tape is calculated, which is 1.1853 e negative 8 coulombs. And then there's some assumptions, right? First of all, air resistance is ignored. Long tape is treated as a point charge. Each U tape has the same charge. Charge is evenly distributed among the tape. Now, these assumptions, obviously, in a real setting, it's probably not true, right? These assumptions are made for the simulated ideal environment. Yes, the charge would be 1.185 coulombs, and if the gravitational and electric force are exactly the same, and if the assumptions are true, then yes. However, realistically, this is not true, right? There's so many things that could have happened. The charges would have been altered from inconsistent measurement of the tape properties, such as the length or the mass or the distance, and then every time that tape touched anything, that would have shifted the charges. So yes, in an ideal environment, that 1.19 coulombs would be correct of a charge, but realistically, that's probably not true. Some additional questions. What if electrons had positive charge and protons had negative charge? What would change with the observations you made with your tapes and other charged objects? Well, even if they were flipped, right, the tape would still repel as long as the charges of both objects are the same. So even if both the tapes were positive charged, then the same thing would happen, right? They would go away from each other. And with neutrally charged objects like a water bottle or some other objects, then they would still attract, because regardless if the tape is positive or negative, they would attract neutral objects. Why is it important to handle the charged tapes as little as possible? What happens when the charged tape comes into contact with your hands or other objects? Well, every time the tape touches, anything, like even if it's neutral, the electrons are passed on to the other object. As the tape loses electrons in charge, its interactions will be less strong. So in the experiment, you can't really see the floating effect anymore. So it's quite important to not have any touching. Thank you, and that's my video.